Hello, welcome back to BLENDERSUSHI live noding. In this video, I'm going to explore animation nodes, and the idea is to kind of animating between two states, but with added randomness to it. So if you imagine that an object can start from the center of the world, and then it moves to another state, and then perhaps it goes back to 000, or perhaps it goes to the next state, but it's kind of doing it randomly. I try to do this kind of in a procedural kind of way. The motion is a little bit like maybe a little bit like the voids, like a dumb, so a little bit dumb kind of insects. It just move around like that procedurally. It creates some sort of kind of like living creature, but I will do it with a single object for now. I still don't know how this can be implemented. Maybe there are many clever ways you can do this. Perhaps you create a list of vectors, and then you kind of move the objects from one state to another state, but with a little bit of delay. That might work. That's probably the most efficient way we can think of. But anyway, we start with something. This is gonna be two states demo. I'm probably gonna improvise near the end, but we start with something first. So random vector and another random vector. With one, I'll just keep it like 0. The other one can be a value. So one is always 0, 0, 0. The other one can be any value within this range. I will turn this always off and then turn that on. Okay, we have these objects on the in 3D. Object transform output. I'll grab the cube, and we're just gonna deal with locations. We don't worry about orientation yet. Okay, let's see. We can use something like mix vector or animate vector. Which one is better? Which one is better? I think animate vector is good for it has a lot of more options within one node. That means less freedom to kind of make your own, but this one is kind of more basic. I might use the mix vector, but this one's also interesting. It has time and duration. Time, duration, linear. I'll try with mix vector first, so it's simpler. So we have these two values. One is at 0, 0, the other one at some random points within this scale range. Plug this into the location. We have this clamp vector, and so basically at this moment our objects will move between two states. The vector can be any value. It can go even lower than 0 and higher than 1. We can clamp the vector, so it's only like the vector will be between 0 and 1 when it's make movement. So 0 and 1, and this can be any value. Maybe I'll make it like scale 10, so it's a little bit further down. So the idea is just really just these objects can move to another state and then go to the next point. Maybe I randomize this one and then move to the next one and the next one. So it creates like a random kind of motion. let's see how we can create that. Maybe with the vector we can, because it goes from goes between 0 and 1, we can use like a sine wave first of all. So we're gonna use frame, of course. So the frame is gonna be the input value that's driving everything. Math sine wave here. Sine. Okay. So the sine frame plug into the sine, it's gonna create like a kind of a little bit like ping pong value. We need a multiplier here, so we'll make the times a bit slower. Let's check with the debug node. So let's have a look. The value should go from -1 and go to 0 to 1. So that's a sine wave. But for what we are doing here, of course, the clamp will clamp the vector, but we need to remap the value here. So instead of -1 to 1, we want it to be maybe between 0 and 1. Let's have a look. There is this use interpolation thing that I rarely use, but still kind of figuring it out. After this time, I'm still kind of figuring thing out. But here you go. So our object is moving back and forth because it's a sine wave. Okay, the value is controlling this guy between two states. What I'm thinking to do is when this guy is moving to 0, 0, 0, I really want to kind of switch the seed here. So when it is at 0, 0, 0, I can switch the seed, so he moves to another place, and then back to 0, 0, 0, and I switch again. So that's the plan. And here currently it's just a kind of back and forth between two values. But since we have this clamp vector, we can have a value smaller than 0 and bigger than 1, and then it's gonna have this kind of pause. See, there's a pause. It's gonna go to that point, and then it goes back to 0, 0, 0. And here I can change the seed, and then he moves to another place, back to 0, 0, 0. Change the seed again. So this creates kind of a unlimited procedural animations for that guy over there. Maybe if we have like a lot of objects like this, we can get like a interesting result. It's a bit slow at the moment. Maybe multiply this by 3.3. So it's doing that. So I need to kind of increase the seed here every few clicks. How do I explain it? So maybe, so by default, time always it goes up 1 frame for each click. Okay, we can make it using the math. There is something called floor division. Floor division is interesting. It's same as expression. It's same as this expression. If we I plug in the frame into that guy. The frame is I'll call it frame. If the frame divided by 5, for example, you see I use double slash. That means that's the floor division, if I'm not wrong. What's happening here is, see, I'm moving in a timeline, and the normal value should go up. So see, that's the normal value 0, 1, 2, 3, 4, 5, 6, 7, 8. But this guy with the floor divisions, whenever it has like a fraction, it's gonna floor it. It's gonna push it back to the previous value. So it's gonna do a pattern that's more like 0, 0, 0, 0, 0, and then 1, 1, 1, 1, 1, 2, 2, 2, 2, 2. So it's like it's holding the value for a few frames depending on this value. Maybe I call it it's gonna be integer. Let's see, this is gonna be x. Integer input. So this is gonna be in x. So 5 meaning it's gonna hold that value for 5 frames. So that's something we can use, and we already have it here as a floor division. So plug this into the seed because I want the seed. Whoops, not this guy, but that guy. The second state. So let's have a look. Maybe currently the delay is not long enough. You kind of need to know that how long is the actual durations of animations. I have a feeling that maybe using animate factor it's much easier to generate this. So currently, okay, the frame, if I make it 5 input, that's gonna give the delay maybe I'll make this between -20 and 20, and then the delay is maybe 20. Maybe this can be 10. This can be 10. And I need to increase the timeline as well. Make it 10,000. So when it's at 0, 0, 0, it should start going up in a click. Okay, this should be longer. Yeah, at this stage a little bit difficult to see what's happening, but yeah, basically we have two states, A and B, and then should go back and forth, and but the B should change every time. Maybe I should make the A changing all the time as well in the seed. Wonder if that's more interesting. Make it a little bit faster. Yeah, I guess that's kind of behavior that I was looking for, except that I don't want it to jump. Although this kind of motion is something you might see in the mosquitoes sometimes. Oh no, the mosquitoes are like flies or kind of like really dumb kind of insects. It's moving with this kind of jerky pattern, kind of random, and then sometimes move really fast, sometimes kind of slow down, and then looks around, and then that's kind of jerky kind of pattern. For me, that's kind of interesting. That's for insects. Let's save this as something. I have a feeling that animate vector can also be interesting. Let's have another one. Monkey. And you get the monkey, Suzanne. Okay, and this time we will use that guy. So we still have a kind of random value. So the vector we have, okay, we need random vector and something to do with floor division, and we have this, and we have time and duration. The time, okay, time frame. We actually have this handy repeat time that can do ping pong and loop, so kind of simulating sine wave with ping pong. So that can be used as well. Kind of, I don't really like the jump there with the monkey. It needs to do it in a more elegant kind of way. Animate vector durations 20. Start and end. Start and end. Okay, duration maybe need to match. And this also need to match. Currently the monkey is kind of doing it. It's a but it makes a jump. It's kind of currently, if we kind of random line pattern, while the box, sometimes the box has a nice transition between states. Let's see, the monkey linear, we can make it maybe bouncy. Ping pong maybe rate 40. Maybe, okay, back to linear first. Ping pong is doing a frame, so frame rate with ping pong goes from 0 to 40 and back to 0, I think. So goes to 40, back to 0, while animate vector really just requires value that go from 0 to 1. So if we use map range, So with the ping pong, okay, 0 to 40 ping pong become minus 40 to 40 or minus 20 to 20, and use another map range from minus 20 to 20 to 0 to 1, or maybe minus 5 to 5. Okay, minus 10 to 10, climb input, and minus 1 to 1. Maybe that's more interesting to see. With this, another way we can so apparently the click, I know this click is not it needs to be delayed somehow. One of them is a bit delayed with the other, so it's more like, I have a feeling it needs to be like this. Basically the result I really want is let's say if we have like a random vector, how many, oh, okay, this is the older version of animation node, so we need to, in order to have multiple random vector, I need to use loop. So this is basically what I'm trying to do. The output is vector list, so this is generate vector list. This is plug to index, this is the vector, and the output is this guy. How many times? Maybe 10 of this guy with a scale is the scale, and the outputs is gonna be vector list. Debug list. So that's a, and we have control over the scale, and then we can have how many vector we want, and that's a one. The seed also needs to be affected, so that's actually this should be the seed. Plug into the index math. Okay, something like that. So sorry, at the moment I'm just improvising. So what I really want is kind of a mix of these two. If I have another one of these, same 10 and different seed, and I will have maybe a torus and object instancer. Get the torus, maybe make 10 of this guy, and loop all all of these, and then we have vector list. Plug this guy there and this guy there. Inside here we have you can have the animate vector. So one state, another state, and the objects we're gonna be transforming. Location. So there, something like this. See the scale, something like that. Okay, it's two different states, and the time if I increase, okay, the duration maybe five frames. So time from 0 to 1, from one state to another. And then it stops with a delay, and then this one change the value. And then the next iteration is going to be changing. So that's the idea actually. Iterations. Wait, iteration is not. It's the seed that I want to change. One state, another state. Change the seed. So from here, and then okay, that's 0, 0, 0. Goes to 1. Probably I'll do it manually now. Frame loop. Frame. It's gonna be a looping value going up and down. Repeat time. So this is time. Rate is gonna be ping pong. Rate maybe 10. Remap the value. So 0 to 10 become -5 to 5. Durations maybe 2. Let's hide this box in the monkey for now. Hide this master. Okay, it's kind of doing it, and then every time it goes to the second one, I have to change the seed. So that's kind of the plan. So the seed needs to change really based on all these kind of durations. It's a little bit complicated to explain this, but you get the idea. I want to change the tick every time it goes to in the state A, B, change the seed. When it goes to A, when it's at A, B need to change the seed because and then the value can change in the background, and then it goes back to B, and then A change the seed. So it's a back and forth. Yeah, I think I have all the idea is there. I have to think of the right value here to change the seed. How many? I think it's as easy as giving the right value. So frame and flow divisions. Please plug into the seed. So I give it 5. maybe set 10. Plug this to the other guy. Kind of almost there. That's actually the full speed. It looks like that. Almost there, but I think the pattern needs to be adjusted. But this is kind of a, I think the thinking idea behind a behavioral real for creatures. I think that's the word I was looking for. The cool thing about this is that we can always have a lot more of this guy. At the full screen and then have a look. Currently, each one of them kind of moving at the same time. That's also something needs to be. I need to figure it out. Maybe they need to move in with different offset and those kind of things. It's actually an animation problem, but it's procedural animation problem. Probably easier when we are using like a sound, but dealing with multiple objects like this, it's really can be complicated, I guess. But yeah, it's interesting. In the end, it's more like it's almost like a texture pattern. Perhaps we can drive all this guy using noise anyway. It's what I like about this is a kind of, it needs to move and then it needs to hold. That's the fun foundations. It's the whole thing that's I think a little bit confusing, because the value what I could think of at the moment is a hold is when a value goes over. So we have like an input, and if the inputs kind of like goes ups and down, and if we clamp the value, cut the value, and then whenever it's black, it's the value is in the hold. And when the character is in the hold, that's actually when it's interesting happens. You know, it's a put characters moving hold, and then it's after it stops, it goes to the next state, yeah, that's what I'm trying to understand, what I'm trying to do in this live noding video. I guess it's still pretty simplistic, but I guess that's all right for now. Yeah, anyway, that's pretty much for today's live noding. It's a little bit complicated, sorry about that. But if you have any input, comments or feedbacks, just let me know down below. Thanks again for tuning in. I'll see you in the next video.